Imagine waking up one morning and the sun is already wrong. Not hidden by clouds, not dimmed by smoke from a nearby fire. Just wrong. Weaker. Paler. Like someone turned down a dial on the sky itself. You go about your day, but the light never quite arrives. Noon looks like late afternoon. Shadows fall at strange angles. The air carries a dry metallic haze that nobody can explain. You wait for it to pass, it doesn't. Days become weeks. Weeks become months. And slowly, horribly, you start to realize this isn't weather. Something has changed. That was the reality for millions of people living through the year 536 AD. And the year after that. And the year after that. A Byzantine historian named Procopius wrote that the sun gave forth its light without brightness, like the moon, during this whole year. He wasn't writing poetry. He wasn't exaggerating for dramatic effect. He was describing something he either witnessed himself or heard from people who had. Across the Mediterranean world, across Europe, across Asia, scribes and scholars and farmers and monks were all recording the same thing. The sun had gone dim, the seasons had gone wrong. Summer arrived, but the warmth didn't follow. So here's the question that should keep you up tonight. What on earth, and I mean that literally, what on earth could do that? No factories, no nuclear weapons, no industrial pollution, just a world of wood and iron and sail and stone. And yet somehow the sky over an entire hemisphere went dark. Not for a day, not for a week, for years. Whatever caused this wasn't local. It wasn't a forest fire or a desert storm that one region could shrug off. Something loaded the upper atmosphere with enough material to act like a filter between the planet's surface and the sun itself. Temperatures dropped. Growing seasons shrank. Crops that had fed empires for centuries started failing, not in one bad year, but in a relentless grinding sequence that left granaries empty and people desperate. And desperate people in a world already under political and military strain become something more dangerous than just hungry. Because here's where it gets genuinely terrifying. The dimming sky was only the first domino. Behind it came harvest failures and food price shocks that pushed ordinary people toward the edge. Behind that came unrest, weakened immune systems, and malnourished populations crowded into cities and trade routes. And waiting behind all of that, gathering strength in exactly the kind of conditions it needed, was one of the most devastating pandemics in human history. The Plague of Justinian, the ancient world's version of a perfect storm, and the volcanic winter of 536 may have loaded the gun. Now, before you click away thinking this is just another doom story about a civilization falling apart, let me be clear about something. This isn't purely an apocalypse story. The world didn't end in 536. People survived. Societies adapted. Some even changed in ways that planted seeds for what came later. This is a story about fragility in Cascades, about how systems that seem permanent and immovable can crack along invisible fault lines when the right pressure is applied, and about what it actually takes for a complex civilization to bend without breaking. What makes 536 so extraordinary to study now is that we don't have to rely on ancient testimony alone. Scientists have spent decades pulling evidence out of places the original witnesses never imagined. Ice cores drilled from Greenland and Antarctica carrying chemical fingerprints of ancient volcanic eruptions locked in layers of frozen time. Tree rings from ancient forests recording cold summers as narrow bands of stunned growth. Sediment layers from lake beds preserving the chemical signature of disrupted growing seasons. We can match what the historians wrote to what the planet itself recorded, and when those two lines of evidence converge, the picture that emerges is extraordinary. We are going to follow that evidence together, from the first eyewitness accounts all the way through the geology, the climatology, the archaeology, and the human consequences on every major inhabited continent. By the time we're done, you will understand not just what happened in 536, but why it matters right now. Before we go further though, I genuinely want to know where you are and what time it is for you right now. Drop it in the comments. Seriously, every time I check, it's someone in Seoul just waking up and someone in Sao Paulo just going to sleep, all watching the same video. There's something about that connection across time zones that fits perfectly with a story about how a single event once rippled across the entire human world simultaneously. Because that's exactly what 536 was. Let's go find out what started it. The first place historians always go is the written record. And for 536, there actually is one. Multiple sources from multiple regions, written in multiple languages, all describing something that sounds like the same event. That's unusual. Most catastrophes in the ancient world get recorded by one culture, maybe two, if you're lucky. The fact that 536 shows up in Byzantine Greek, in Latin chronicles from Western Europe, in Syriac texts from the Middle East, and in records from as far away as China, that alone tells you this was no regional curiosity. Let's start with the most cited account, because it's the one that launched serious modern investigation into this period. Procopius of Caesarea, a Byzantine official who served under the general Belisarius during Justinian's campaigns, wrote in his history of the wars that the sun gave forth its light without brightness, like the moon, during this whole year. He placed this observation around 536. Now, Procopius was a sophisticated writer with political axes to grind. He wrote 3 different accounts of Justinian's reign, one flattering, one scathing, one that reads like gossip. So the first instinct of any good historian is to ask whether he's embellishing. But here's the thing. This particular observation isn't in a polemical passage. It isn't being used to praise or condemn anybody. It's dropped almost incidentally as a factual description of conditions during a military campaign. That kind of offhand reporting often carries more weight than deliberate set pieces. Still, one source proves nothing. What we need is corroboration. Cassiodorus, a Roman statesman and scholar serving in the Ostrogothic court in Italy, wrote a letter around the same period describing a sun that appeared to have lost its wonted light, describing a bluish discoloration and a pervasive dry mist that hung over the landscape. He noted that the summer heat was feeble, that frosts continued into months when they had no business appearing, and that the harvest was failing as a result. Crucially, he described the moon at night as appearing bloodless, stripped of its reflected brilliance. Now, Cassiodorus was not a neutral observer either. He was a court administrator writing letters meant to project calm and competence, which makes his inclusion of these atmospheric details even more interesting. If the sky had been merely overcast or slightly unusual, he probably wouldn't have mentioned it at all. You don't alarm your administrative network over a cloudy week. The fact that he wrote about it suggests it was abnormal enough that ignoring it would have seemed stranger than acknowledging it. John of Lydus, another Byzantine writer, described the sun as having become dim for nearly the whole year. Michael the Syrian, writing much later, but drawing on earlier sources, preserved accounts of a dry fog, a darkened sun, and failed crops from roughly the same period. The Syriac chronicle tradition is sometimes dismissed because these texts were compiled and copied centuries after the fact, which means errors and interpolations are real possibilities. But the specific details they preserve, the duration of the dimming, the unusual atmospheric haze, the disrupted growing seasons, these match too closely with independent sources to write off as contamination. Here's where historical method matters. None of these writers knew each other's work well enough to have simply copied the dramatic bits. They were writing in different languages, from different political contexts, for different audiences. They disagreed on plenty of other things. What they agreed on was the sky and the cold. That pattern of independent convergence is exactly what historians look for when trying to separate genuine, widespread events from regional folklore or literary borrowing. That said, you have to keep the caveats honest. Ancient chronicles are not meteorological instruments. They are human documents shaped by purpose, audience, education, and the particular cultural frameworks through which their authors interpreted the world. A Byzantine intellectual would describe an unusual sky in terms inherited from classical natural philosophy. A monk in Ireland would frame the same phenomenon in terms of divine warning. A Chinese court astronomer would record it as a portent, requiring ritual response. These different frameworks don't make the observations wrong, but they do mean you have to read past the interpretive layer to get at what was actually being reported. The Irish annals, particularly the Annals of Ulster and related chronicles, record famine conditions in the late 530s. They don't describe the sky in the vivid terms the Byzantine writers used, which is worth noting. The Irish sources were primarily interested in political and ecclesiastical events. A monk compiling a chronicle of abbots and kings wasn't necessarily watching the horizon for atmospheric oddities. What he recorded was hunger, death, and disrupted harvests, the downstream consequences rather than the physical cause. This is a reminder that the absence of sky descriptions from certain regions doesn't mean those regions were unaffected. It might just mean that particular scribe had different things on his mind. Chinese records from the Northern Wei and subsequent dynasties during this period describe unusual cold, unseasonal frosts, and what one source calls a yellow dust falling like snow. This is interesting because yellow dust has a specific meaning in East Asian meteorology. It usually refers to Gobi Desert sediment carried on high-altitude winds, but the context in these accounts suggests something different. Something atmospheric that was causing cooling and dimming. The dating of these Chinese records relative to European sources has been a matter of ongoing scholarly debate, with some researchers arguing the Chinese events they describe might refer to slightly different years or different atmospheric episodes. But the broad cluster of unusual weather records from across Eurasia in the mid-6th century is too consistent to dismiss. So what's actually consistent across all these sources when you line them up? A few things stand out. First, duration. This wasn't a single day or week of unusual light. The sources that give any temporal indication suggest the dimming persisted for months, with some accounts implying reduced solar intensity extending across multiple growing seasons. That's not a dust storm. That's not a regional wildfire. That's something deposited high enough in the atmosphere to linger long past any ordinary weather cycle. Second, the quality of the light. Multiple independent sources describe a sun that was still visible, still above the horizon, but somehow weakened. Not blotted out, not hidden behind clouds, just wrong. Bluish, pale, moon-like. That specific quality, a sun that shines without warmth, a sky that is bright but cold, is a reasonably coherent physical description of what happens when fine particulate matter is distributed through the stratosphere. The light gets through, but the thermal energy doesn't, or at least not in the same proportions. Third, seasonality was broken. Frost in summer, abnormal cold persisting into months that should have been warm. Procopius and Cassiodorus both note this. The Irish annals record it indirectly through famine. The Chinese sources note unseasonal cold. This pattern of disrupted seasons is consistent with reduced solar heating at the surface, exactly what you'd expect if something was filtering out a portion of incoming solar radiation. What the sources do not give you is a unified, universal description. They don't all agree on the colour of the haze. They don't all give the same start date. They don't all describe the same severity. Some regions seem to have recorded more intense effects than others. And some areas that you might expect to have left detailed records simply don't, or if they did, those records haven't survived. Large parts of sub-Saharan Africa, most of the Americas, much of Southeast Asia, These regions are simply silent in the written record for this period, not because nothing happened there, but because either the documentary traditions were different or the documents didn't survive. This is the honest reality of working with ancient written sources on something like this. You have a handful of independent, geographically distributed accounts that agree on the broad outlines but differ on the details. They collectively suggest something very real happened to the sky over Eurasia in the mid-6th century. But written testimony alone can't tell you the cause, the magnitude, or the precise timing. It can't tell you whether what Procopius saw in Constantinople was physically identical to what a scribe in Syria or a monk in Ireland experienced. It can tell you that across a vast region, educated and literate people thought the sky was behaving in ways strange enough to write down. And that's actually a remarkable threshold to clear. The ancient world was not easily frightened by weather. These were people who lived outdoors by modern standards, who understood seasonal variation intimately, who had seen droughts and storms and floods throughout their lifetimes. When they stopped and wrote about the sun itself looking wrong, they were telling you something extraordinary was underway. The question is what? And to answer that, you have to leave the libraries and go somewhere much colder. Because while the chroniclers were scratching away at their parchment, the planet itself was keeping a different kind of record. One that doesn't exaggerate, doesn't have a political agenda, and doesn't lose pages to fire or war. It just accumulates, layer by layer, year by year, frozen in the dark. So what kind of event can make the sun look wrong for a year or more across half the world without actually turning day into night? To get there, you have to think like the atmosphere. Most of the weather we experience lives in the lowest slice of air, the troposphere, the turbulent layer where clouds form, jets fly, and storms churn. It's chaotic, constantly stirred, and anything you dump into it tends to get rained out, washed out, or blown away in days to weeks. Above that, starting around 10 to 15 kilometers up, depending on latitude, is a very different realm, the stratosphere. It's cold, stable, and stratified, with far less vertical mixing. If something manages to punch material all the way up there, it can linger. Months, even years, and once it's in that layer, sunlight has to pass through it every single day. The key actors in our story are not big chunks of ash or clouds we could see and photograph. They're aerosols, microscopic particles and droplets suspended in the air. On their own, each is trivial, a speck measured in micrometers. Collectively in the right place and concentration, they can rewrite the energy budget of the planet. Here's how. Sunlight coming in from space is mostly visible and near infrared light. When that light hits clean air, most of it comes straight through to the surface, gets absorbed by land and ocean, and is then re-emitted upward as longer wavelength heat radiation. Greenhouse gases affect the outgoing heat. Aerosols mess with the incoming light. If you spread a veil of tiny particles through the stratosphere, several things happen at once. Some of the sunlight is scattered back into space before it ever reaches you. Some is scattered sideways, diffusing the light so that shadows get softer and the sky looks hazy. Some wavelengths are scattered more efficiently than others, changing the apparent colour and intensity of the sun. To someone standing on the ground, the disk of the sun can still be visible, still seemingly high in the sky, but its punch is gone. It looks pale, washed out, almost like a full moon seen through thin cloud. You get the light without the heat, exactly the sort of thing Procopius and Cassiodorus were trying to describe with their limited scientific vocabulary. This is not just theory. We have seen modern, instrumented versions of this play out. In 1991, Mount Pinatubo in the Philippines dumped millions of tons of sulfur dioxide high into the stratosphere. Chemical reactions turned that gas into a global blanket of sulfate aerosols. Over the next year, satellite measurements showed a clear increase in how much sunlight the Earth was bouncing back into space. Thermometers showed the result. Global surface temperatures dropped by around 0.5 degrees Celsius. That doesn't sound like much, but averaged over the whole planet it's enormous, roughly enough to shave a few weeks off the growing season across large regions. One eruption, one pulse of sulfur, one thin veil of droplets, and the sun temporarily got weaker. This gets you to the main suspect for 536, volcanic sulfate haze. When a volcano is powerful enough to blast sulfur gases directly into the stratosphere, those gases oxidize and form tiny droplets of sulfuric acid. These droplets are exceptionally good at scattering sunlight. Unlike big ash particles, which fall out quickly, sulfate aerosols can stay lofted for a year or more, gradually spreading around the hemisphere, sometimes around the entire globe. The result is a kind of high-altitude invisible sunshade. But volcanoes are not the only way to throw aerosols into the sky. Huge wildfires inject smoke. Dust storms can loft enormous amounts of mineral dust. Deserts, drying lakes, and even human land use can produce hazes that last for weeks. If all you knew was the sky was weird and it was cold, you might be tempted to point at any of these. So it matters to understand how they differ. Wildfire smoke is rich in black carbon and organic particles. That kind of aerosol can absorb sunlight as well as scatter it. Depending on where it sits, it can actually heat the air layer it occupies while shading the surface below. But large wildfire plumes mostly stay in the lower atmosphere. They get rained out with the next storm system. Even in extreme fire years today, smoke episodes that truly dim the sun in any given location typically last days to a few weeks. They're also patchy and regional. Your neighbours a continent away don't necessarily notice. Dust storms have their own signature. Mineral dust grains are larger and heavier than sulfate droplets. They tend to settle out faster, and they interact with light differently. Dust can indeed redden the sun, create dramatic twilights, and reduce surface heating. But to sustain a dust veil that weakens summers for multiple years across Eurasia, you'd need a source and transport system on a scale we've simply never seen recorded, even in the dustiest periods of recent history. And again, dust is primarily a tropospheric phenomenon. It lives in the weather layer, and the weather layer cleans itself. There is a third category people sometimes invoke, cometary or meteoritic dust. An impact or a close pass could, in theory, inject fine material into high altitudes. That kind of scenario shows up regularly in more speculative literature, about 536. The problem is that large impacts leave other traces, craters, shocked minerals, global fallout layers of specific composition. So far, nothing from the mid-6th century convincingly matches that fingerprint. What makes the 536 dimming stand out is not just that the sky looked strange, but that the strangeness seems to have persisted through at least one full growing season, and, in some reconstructions, part of a second. That kind of persistence is a hallmark of stratospheric injection. You can think of it as an altitude test. If the anomaly lives in the troposphere, ordinary weather processes, convection, storms, rainfall, tear it apart and remove it relatively quickly. If it makes it into the stratosphere, above most of the turbulence and the rain, it sits there and slowly circles the globe. The residence time jumps from days and weeks to many months. The chronicles line up with the long tail, not the short one. Now, why does that matter for people who never heard the word stratosphere? Because crops don't care why the sun got weaker. They only care that it did. Most traditional agricultural systems in late Antiquity were finely tuned to local climate rhythms. Farmers knew within a couple of weeks when the last frost usually came. They knew how long the soil would take to warm. They knew approximately how many frost-free days their staple grains needed to reach maturity. Take away even a small fraction of incoming solar energy, and several things go wrong at once. First, spring arrives late. with less radiant energy reaching the ground, soils warm more slowly. Bud break, germination, flowering, all the temperature-sensitive steps in plant development are delayed. Seeds go into cold earth and just sit there. Second, frost risk stretches further into the calendar. Nights that would normally hover just above freezing dip just below it. A single hard frost at the wrong point in a plant's life cycle can kill flowers, damage young leaves, or abort developing grains. The chronicles that talk about frost in months when it had no business appearing are essentially describing this boundary being pushed. Third, even on warm days, photosynthesis runs under a handicap. Plants are solar machines. Their entire metabolism is built around capturing light. A dimmer sun means slower growth, thinner stems, lower yields and crops that simply fail to reach maturity before the season ends. Add in disrupted rainfall patterns because a cooler surface also means weaker evaporation and altered storm tracks, and you get stressed plants dealing simultaneously with cold and moisture anomalies. That's a very efficient way to turn a marginally stable food system into a famine engine. You don't need permanent darkness. You don't need glaciers sweeping down from the mountains. All you need is for 2 or 3 growing seasons in a row to be just bad enough, across enough regions that granaries start empty and never quite refill. Prices spike. People sell land, tools, even children to survive. Local political crises flare as elites try, and sometimes fail, to manage scarcity. So if you put the physics and the testimonies together, a picture starts to cohere. Something injected a massive load of reflective aerosols high into the atmosphere, dimming the sun, cooling the surface, and skewing the seasons long enough to wreck harvests across large parts of the northern hemisphere. That something has an obvious modern analogue in large explosive volcanic eruptions. Pinatubo in 1991, El Chichon in 1982, Krakatau in 1883, Tambora in 1815, each of these produced measurable, sometimes spectacular, global or hemispheric cooling in the following years. They demonstrate, with hard data, that volcanoes can in fact do the sort of thing Procopius was struggling to describe. But can is not the same as did. Not every major eruption sends sulfur into the stratosphere. Not every stratospheric injection produces the same pattern of cooling. And the mid-6th century appears to have been a period of repeated shocks, not a single clean event. When you look at the physical evidence locked in ice cores and tree rings, the story becomes more complicated. Multiple signals, clustered in time, some stronger than others. That's why the debate among scientists is not volcano or no volcano, but which volcano or volcanoes, and whether something else might have been amplifying or modulating the effect. To push beyond possibilities and into probabilities, you have to leave the conceptual physics and look for fingerprints, chemical traces of sulfate in polar ice, annual tree growth patterns that register cold summers, and the specific timing and geography of known eruptions. Only then can you start testing whether the dim sun of 536 was the work of one colossal eruption, a cluster of them, or a more exotic combination of forces. For that we have to dig into the planet's cold archives, where every year of ancient sky has been quietly recorded, not in ink, but in layers of snow and frozen wood. If you want to know what the sky was doing in a year no one alive remembers, you don't start with chronicles. You start with ice. In Greenland and Antarctica, snow falls year after year, century after century, piling up into layers that slowly compress into ice. Each year's snowfall traps tiny bits of the atmosphere, dust, sea salt, microscopic ash, even bubbles of ancient air. Stack up enough of those layers and you get a frozen library of Earth's climate history written in chemistry instead of ink. Volcanic eruptions, especially the big sulfur-rich ones that matter for our story, leave an especially clear mark. When a volcano blasts sulfur dioxide into the stratosphere, it spreads out and reacts with water to form sulfuric acid droplets. Over months to a few years, some of those droplets fall out, either directly or riding on snowflakes, and get locked into the polar ice as a thin sheet of sulfate. To the naked eye, that layer might look no different from the snow above or below it, but run a thin slice of the ice through a sensitive analyzer and the sulfate jump is unmistakable. A sudden spike in acidity, often accompanied by trace amounts of volcanic ash, tiny glass shards called tephra that carry a chemical fingerprint of the magma they came from. In principle it sounds simple. See spike, read date, match to event. In practice, turning those spikes into a detailed timeline is one of the hardest forensics jobs in earth science. First, you need to know exactly how old each layer of ice is. Near the surface, this can be surprisingly straightforward. In some Greenland cores, you can literally count annual layers like tree rings, because summer and winter snow differ in density and chemistry. Summer snow might carry more dust or have a distinct ratio of certain ions. Winter snow looks different. With careful work under a microscope and in the lab, you can tick off years one by one. Deeper down, the story gets harder. Layers get thinner as the weight of overlying ice compresses them. Flow within the ice sheet can stretch and distort older sections. At some point, the neat banded pattern blurs and you have to rely on indirect clues, known volcanic markers like Tambora in 1815 or Krakatau in 1883, weird spikes in cosmogenic isotopes from solar storms, or changes in trapped greenhouse gases that you can match to independent records. Scientists build what are called ice core chronologies, carefully tuned year-by-year calendars that line up those internal signals with known external events. And they don't do it in just one place. They compare multiple cores from different parts of Greenland and then link those to cores from Antarctica, always looking for the same volley of volcanic sulfate appearing with the same spacing in time. Think of it like trying to synchronize a bunch of old clocks that have been running at slightly different speeds for centuries. You're constantly cross-checking. Does this big spike in Greenland show up with the right lag in Antarctica? Does the spacing between two large eruptions match between cores? Are there independent anchors like historically documented eruptions in Iceland or the tropics you can use as pegs to tighten the alignment? By the time researchers turned this machinery onto the 6th century, they already had a rough map of the last 2,000 years. They knew what a Pinatubo scale spike looked like. They knew what a Tambora scale, year without a summer eruption, looked like. And when they zoomed in on the decades around 536, the ice jumped off the graph. In Greenland cores, there's a sharp, prominent sulfate spike, starting around the mid-530s depending on the chronology, often placed at 535 or 536. In some cores, it's not just a single pulse. It stretches for several years, with a high peak and a tapering tail. Exactly what you'd expect from a large stratospheric injection gradually washing out of the atmosphere. The amount of sulfate in that layer is huge. Different reconstructions vary, but many put it in the same league as some of the largest eruptions of the last few millennia, and possibly larger than Tambora. Translate that into sulfur dioxide, blasted into the sky, and you're talking tens of millions of tons. Enough to create a global veil of aerosols, enough to nudge planetary temperatures down for more than a single season. Then, a little further up the core, that is, a few years later in time, another spike appears. Not quite as big in some records, but still substantial. Many chronologies place this second pulse around 540 or 541. Together, the two form a 1-2 punch. A major eruption in the early or mid-530s, followed by another, likely also stratospheric, less than a decade later. Antarctic cores tell a similar, but not identical tale. They also show sulfate peaks in the same general window, mid-530s and around 540. The details differ. In some Antarctic records, the earlier peak is muted, and the later one stronger. That pattern suggests at least one of these eruptions was tropical, sending aerosols into both hemispheres, and that one might have been skewed toward the northern hemisphere, hitting Greenland harder. When you see spikes of this magnitude lining up, within a few years' uncertainty, in both polar caps, you can say something important with a fair degree of confidence. The mid-6th century experienced at least one, and probably two, large sulfur-rich eruptions with near-global reach. That by itself does not prove those eruptions caused the dim sun of 536. But it makes the volcanic explanation much more than a just-so story. It shows that the atmosphere was in fact flooded with volcanic sulfate at almost exactly the time chroniclers were complaining that the sun had turned pale and summers had gone missing. There are catches though, and they matter. Dating ice cores is not a perfect science. Different research groups use slightly different chronologies. For the 6th century, the uncertainty in Greenland and Antarctic cores can be on the order of a few years either way. That means a sulfate spike that one team labels 535 might be 537 in another reconstruction. When you're trying to line those spikes up with historical texts that don't always give precise dates, that wiggle room introduces ambiguity. Deposition is also messy. Not every eruption sprinkles sulfate evenly over the poles. Wind patterns, storm tracks, and the latitude of the volcano all shape where the fallout ultimately ends up. An eruption in Iceland might plaster Greenland with sulfate but leave only a faint trace in Antarctica. A huge tropical blast might show up cleanly in both, but with different timing and intensity depending on how atmospheric circulation carried the cloud. Resolution is the third issue. For some cores, especially older ones, a single annual sample can blur together several months of snowfall. If two smaller eruptions occur less than a year apart, their sulfate can merge into one broad bump instead of two clean peaks. Conversely, a very prolonged fallout from one complex eruption might be misread as multiple pulses. Disentangling those signals requires high-resolution measurements and careful modelling, and even then, multiple interpretations can fit the same chemical curve. Put all that together, and you get why the debate over the exact identity of the 536 volcano or volcanoes has been so heated. Iceland, Central America, Alaska, a tropical volcano in the El Salvador-Mexico region, a cluster of them. The ice alone can't name the culprit. At best, it can tell you magnitude, sulfur load, approximate timing, and whether the event likely straddled both hemispheres. But at best here is still powerful. The sulfate layers act as a hard constraint. Any hypothesis for the 536 dimming has to be consistent with big volcanic signals in the ice around that time. You cannot, for example, seriously propose that it was all dust from distant deserts if the ice chemistry screams volcanic sulfur. You cannot move the main event to 520 or 560 without contradicting the clustered spikes the cores actually record. And if you think there was just one eruption, you have to explain why the ice shows two distinct sulfate peaks within less than a decade. In other words, even without a signed confession from a specific crater, the ice cores narrow the suspects dramatically. They tell us that the mid-530s were not business as usual. They were years when the planet's stratosphere was loaded with reflective volcanic aerosols twice. To see how that played out on the ground, you have to compare this frozen sulfate record with another archive that also counts years one by one, but in wood instead of ice. That's where the trees come in, and where the cold summers of 536 and 540 stop being abstract chemistry and start showing up in the growth rings of living organisms. If ice cores are the planet's climate logbooks, trees are the local eyewitnesses. They don't just tell you that something happened in the atmosphere. They tell you how hard it hit the ground, one growing season at a time. Here's the basic trick. In most temperate and some high altitude or high latitude environments, trees lay down a new ring every year. When conditions are good, long, warm growing season, enough moisture, plenty of sunlight, the tree grows fast and the ring is relatively wide. When conditions are bad, cold, short summers, drought stress, late frosts, the ring is narrow, sometimes dramatically so. Under a microscope, you can see even more. Early wood formed in spring looks different from late wood formed toward the end of the season. Density, cell structure, and isotopic composition all shift in response to temperature and moisture. Put those pieces together and you get Dendrochronology, the science of reconstructing past climate from tree rings. Just like in the ice, the power comes from counting. Ring, 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 year after year. Some trees, like long-lived pines and oaks, can cover centuries on their own. When an individual tree dies, you can overlap its pattern with that of younger trees. Old beams in buildings, ancient timbers in bridges, even wooden coffins become pieces of a giant jigsaw puzzle. Match the ring width ups and downs, and you can cross-date them into a continuous timeline stretching back thousands of years. By the time scientists started asking what 536 looked like in the trees, these chronologies were already well developed for large parts of Europe and North America, and improving for Asia. They had libraries of ring sequences from living trees in Scandinavia, ancient larches in the Alps, bristlecone pines in the American West, even buried subfossil trunks preserved in bogs and lakes. When they lined up those ring series against the 6th century, the story that emerged was unsettlingly consistent. In Scandinavia and the Alps, growth in the mid-530s crashes. Trees that had been putting on decent wood for decades suddenly pull back. Where you might expect a smooth sequence of moderate rings, you get a sharp step down, very narrow rings in 536 and 537, often staying depressed for several years. Some chronologies show the worst single year as 536. Others point to 537, likely reflecting local differences in when the cold and cloud cover peaked during the growing season. Look across the North Atlantic and the pattern repeats. In Ireland and the British Isles, oak chronologies show abrupt growth downturns around the same time. In some Irish bog oaks, the ring for 536 is so thin, it's almost a line. Follow the sequence forward and you see a sluggish recovery, with another hit around 540-541, matching that second sulfate spike in the ice. Head farther east, into Central and Eastern Europe, and the signal is still there. Conifers in the Carpathians, pines in Central Asia, different species, different soils, different histories, all record unusually poor growth in that same mid-6th century window. Not every site shows the exact same year as the bottom, but the cluster is unmistakable. Somewhere between 536 and the early 5040s, something knocked down tree productivity across huge swaths of the northern hemisphere. That synchronicity is crucial. A single bad year in one region could be local. A late frost, a freak storm, an insect outbreak. But when trees in Ireland, Germany, Scandinavia, the Alps, and parts of Asia all start struggling within a couple of growing seasons of each other, you're not looking at isolated bad luck anymore. You're looking at a hemispheric climate perturbation, and the way the trees suffer fits what a big volcanic veil would do. Volcanic aerosols don't just cool the planet in winter. They especially hurt summers by scattering and absorbing sunlight right when plants are trying to turn light into growth. In tree ring records that often shows up as cold summer signatures, years when temperature-sensitive trees barely grow even though moisture was not necessarily lacking. In high latitude and high elevation sites, places where warmth limits growth more than water does, the mid-530s look exactly like that. Not so much the fingerprint of brutal drought, but of summers that were short, dim, or both. You can see this not just in ring widths, but in maximum late wood density, a measure that tracks summer temperature particularly well. In some Alpine and Scandinavian records, late wood density plunges in 536, and the years immediately after rivaling or exceeding drops associated with known volcanic years like 1816 after Tambora. But the trees also reveal something the ice alone can't: regional complexity. The planet doesn't respond to a volcanic forcing, like a dimmer switch, turning everything down equally. It's more like whacking the atmosphere with a hammer and watching waves ricochet through wind belts and storm tracks. In some places, the main effect is cooler summers. In others, rainfall patterns shift, monsoons weaken or strengthen, droughts migrate. In parts of Central Asia and the Eastern Mediterranean, some tree ring series suggest not only cooler conditions, but also altered moisture regimes. Certain sites show signatures consistent with water stress, combinations of narrow rings and isotopic shifts that point to drier growing seasons. Elsewhere, trees that are normally moisture limited don't register as dramatic a downturn, perhaps because cooler temperatures slightly reduced evapotranspiration, offsetting some of the damage. In North America, where 6th century chronologies are patchier, there are hints of disturbances roughly in the same window, but the picture is less uniform. That ambiguity matters. It suggests that, while the aerosol cloud likely spanned much of the globe, local consequences depended heavily on geography, latitude, proximity to oceans, prevailing winds. Now connect that to people whose lives depended on an annual harvest. Most pre-industrial farmers were, in effect, trying to grow trees with one-year lifespans. Cereals like wheat, barley and millet are sensitive to many of the same things that show up in tree rings: the length and warmth of the growing season, the timing of spring, the availability of moisture at critical points. If a pine in the Alps barely manages to add a sliver of wood in 536, because the summer was cold and dark, the barley in the valley below is not having a banner year either. Dendrochronology lets us quantify just how unusual those mid-6th century summers were. When researchers stack many tree ring series together and build regional reconstructions of summer temperature, the 530s often stand out as some of the coldest growing seasons of the last 2 millennia. In parts of Europe, only a handful of other volcanic years come close, and usually as single bad summers, not a cluster. That's where the danger lies. A single poor harvest hurts, but many societies can ride it out with stored grain, slaughtered livestock, and emergency redistribution. 2 or 3 bad years in a row, or a pattern where every second or third year is subpar, chew through reserves. Seed stock gets eaten, herds are sold off or die. People lose the buffer that lets them survive the next shock. The tree rings hint that the 53s were not just a one-summer anomaly, but a multi-year period of reduced growth and climatic weirdness, punctuated by at least 2 major volcanic hits. That would have pushed agricultural systems that were already operating close to the edge into dangerous territory. It's also worth remembering that storage technology sets a hard ceiling on resilience. In the 6th century, very few regions could preserve grain reliably for more than a few years, without major losses to rot, pests or theft. Silos, granaries, and clay jars smoothed out normal variability. They were not designed for half a decade where summers never quite show up the way they should. So when the trees tell us that forests from Ireland to the Urals essentially flinched in the mid-530s, shrinking their growth rings, recording stunted summers, we're not just learning about botany. We're seeing the same stress that would have rippled through wheat fields, vineyards, and pastures. The ice says the sky filled with volcanic sulfur. The trees say summers dimmed and cooled across much of the north. Put those together, and the chronicles about a sun that gave no light stop sounding like exaggeration and start looking like human testimony layered on top of a planetary signal. But knowing that there was a volcanic blow and a climatic response still leaves a crucial mystery. Which volcano or volcanoes were responsible? To answer that, we have to leave the rings and cores behind and start hunting for specific craters, ash fingerprints, and the geological suspects that might have plunged the 6th century world into its long twilight. If this were a whodunit, we'd already know the weapon, a big volcanic eruption, or more than one, throwing sulfur into the stratosphere. We'd have a pretty good idea of the time of the crime. 536 for the first hit, around 540 for the second. What we don't have is the suspect. To pin down an exact volcano, scientists are basically looking for 3 things. First, chemistry. Every volcano draws on a slightly different magma source, with its own blend of elements and isotopes. When that magma explodes, it shatters into tiny glassy particles, tephra. Under a microscope and in a lab, those shards carry a chemical fingerprint, a mix of silica, iron, trace elements, even the shape of the glass that can be matched to known volcanoes. Second, timing. The ash layer has to sit at exactly the right place in the timeline. If your ice core or lake sediment shows a thin ash band, you can date precisely to 536, and its chemistry screams this came from Volcano X. You're in business. Third, distribution. A local eruption might dump a lot of ash nearby, but barely affect the global radiation budget. The 536 event, on the other hand, left a sulfate spike in both Greenland and Antarctic ice, and cooled summers across much of the northern hemisphere. That suggests either a very large tropical eruption, whose plume could spread across both hemispheres, or a very powerful high-latitude eruption, combined with atmospheric circulation that carried aerosols unusually far. The ideal case would be straightforward. Find cryptic microscopic ash from 536 locked inside an ice core. Match its chemistry to a known volcano. Double-check that the volcano's own deposits are dated to the same year and call it solved. Reality is messier. For one thing, the ice record hints that we're not dealing with a single monster blast. The sulfate layers point to at least 2 distinct events, one around 536, one around 540, 541. The tree rings back that up with a double punch pattern. A bad mid-530s, a partial rebound, then another downturn. That means we're not just looking for the volcano of 536. We're hunting for a sequence of eruptions, possibly from different parts of the world, whose effects overlapped in time. So where do we look? One line of thinking focuses on high-latitude volcanoes. Greenland ice shows a particularly strong sulfate anomaly around 536, which could indicate a large eruption in the North Atlantic or Arctic region. Candidates have included Icelandic systems like Katla or Elgia, and Alaskan or Kamchatkan volcanoes on the North Pacific Rim. Iceland, in particular, is a usual suspect in climate crimes. It's close to Greenland, capable of huge fissure eruptions, and its lavas are well studied. At one point, some researchers proposed that the Elgia eruption, a massive 10th century event, might have been misplaced, and really belonged in the 6th century. Improved dating shut that down. Elgia is definitely later, but the general idea remains. An as yet poorly documented Icelandic eruption could have thrown enough sulfur into the northern sky to dim summers from Scandinavia to the Mediterranean. Another school of thought points south, to the tropics. The logic here is simple atmospheric geometry. A very large tropical eruption, especially one just north or south of the equator, can inject aerosols that spread into both hemispheres. Tambora in 1815 did exactly that, causing cold anomalies north and south of the equator. In this view, the strong sulfate signal in both Greenland and Antarctic ice, around 540, suggests a big tropical event there, perhaps followed or preceded by a more northern eruption in 536. The candidates, major volcanic arcs that are both dangerous and historically active, Central America, the Andes, the Indonesian archipelago, the Philippines. Over the last couple of decades, attention has swung repeatedly towards specific names. At various times, papers and headlines have pointed the finger at Ilopango in El Salvador, Rabaul in Papua New Guinea, Krakatau in Indonesia, even mysterious eruptions in the Central American volcanic belt, known only from tephra deposits with fuzzy dates. The pattern is often the same. Geologists date a massive eruption to somewhere in the broad neighbourhood of the 6th century. Its size is big enough to matter. Its latitude makes it a plausible climate forcer. For a moment, it looks like we've found our villain. Then someone refines the dating or reanalyzes the ash, and the match slips just out of the 536-540 window. Or the chemistry doesn't line up cleanly with the cryptotephra found in ice and sediments. This is where the distinction between likely volcanic and this exact volcano did it becomes crucial. The physical evidence that the 530s climate shock was volcanic is overwhelming. Sulfate in polar ice, the characteristic tree ring cold signatures, historical descriptions of a dusty, dim sun. At that level, the case is about as strong as the one linking 1816's Year Without a Summer to Tambora. But Tambora left a clear, well-documented crater, eyewitness accounts, and thick ash layers whose chemistry can be compared directly to ice core particles. The 6th century eruptions did not leave written records that survived in the same way, and many of the candidate volcanoes are in regions with limited historical documentation for that period. On top of that, dating older eruptions is hard. Radiocarbon has uncertainties of decades. Tree ring wiggles can introduce small shifts. Ice core timescales get refined as new cores are drilled and synchronized. A volcano that looks like a perfect match for 540 in one chronology might move to 529 or 550 in another, just far enough away to break the alignment. Complicating things further is the idea that we might be dealing with a cascade, not a single trigger. A high latitude eruption in 536 could have thrown a dense veil over the northern hemisphere, hammering European and Asian summers. A few years later, a massive tropical eruption in 540-541 could have renewed and expanded the aerosol burden globally. Individually, each might have been survivable back to back. They could produce the drawn-out, stuttering recovery we see in the trees and chronicles. If that's true, the search for the volcano of 536 is slightly misframed. We may instead be looking for a chain of eruptions, spread across different volcanic provinces, that happen to fall within a single human lifetime. New tools are both narrowing and complicating the hunt. One of the most powerful is cryptotephra analysis. Instead of easily visible ash layers, scientists now routinely scan ice cores, peat bogs, and lake sediments for microscopic volcanic glass shards, sometimes only a few tens of particles in a sample. With modern microscopes and microprobes, they can measure the chemistry of individual grains, building a more precise fingerprint. At the same time, ice core chronologies are being tightened using volcanic markers, known solar variations, and even historical eclipses. Tree ring chronologies are being extended and cross-checked worldwide. Together, these improvements can shift key dates by a year or two, suddenly bringing a previously excluded eruption into contention, or pushing a favourite suspect just outside the critical window. The result is a strangely dynamic mystery. Every time a new core is drilled, a new volcano mapped, or a dating method improved, the list of suspects changes. Some candidates are ruled out, others are resurrected. Occasionally a new, entirely unknown eruption is discovered, a thick tephra layer in a lake, or a buried pyroclastic flow that clearly belongs to around the 6th century, but can't yet be pinned to 536 or 540 with year-level precision. For now, most researchers are comfortable saying this. The mid-530s crisis was almost certainly driven by one very large eruption, and at least one additional major eruption within about a decade, likely involving both high-latitude and tropical volcanoes. Beyond that, names and coordinates remain hypotheses. Does that uncertainty matter? For reconstructing human history, maybe less than you'd think. Farmers in Gaul or Syria didn't care which cone exploded. They cared that their barley failed. But for understanding how the climate system responds to different kinds of eruptions, and how often clusters like this happen, nailing down the culprits does matter. And while the geological detective work continues, the human story moves on. Because regardless of which mountain blew, the ash and sulfur it hurled into the sky had to land somewhere. It settled onto fields, flowed into rivers, and filtered into the lungs and larders of 6th century societies already walking a fine line between subsistence and scarcity. To see what that meant on the ground, we have to leave the volcanoes behind and look at what happens when the climate shock ripples through the one system no pre-industrial society could afford to lose: its food supply. In a normal year, the food system of the 6th century world looked fragile from our perspective, but it usually worked. Most people lived close to the edge, yes, but they weren't idiots walking around with no backup plan. Peasants stored grain in pits and jars. Landowners kept surplus in estate granaries. Cities had a mix of private stocks and, in better-run states, public reserves that could be tapped in emergencies. Trade routes stitched regions together, moving wine, oil, and grain from places with a little extra to places that were short. It was not abundance, it was a balancing act. A bad harvest in one province could be cushioned by imports from another. A local drought might hurt, but it didn't automatically mean mass starvation. The system assumed that while some regions had trouble, others would be doing okay. The 530s broke that assumption. Now imagine you're a small farmer watching this unfold year by year. The first dark summer comes, the sun is dim, the days feel wrong. Maybe that year's harvest is late and light. Yields are off by, say, a third. It's painful, but not yet catastrophic. You eat more from storage. You sell less at market. You mix in more barley, more weeds, more whatever you can scrape together. Those storage pits and jars, many were designed to carry a family or a village through a single bad season. They were not designed for a lost decade. Then the second or third bad year hits. The grain you'd hoped to replace never comes. Seed stocks, your future harvest, get eaten because the present hunger is louder. Animals that functioned as living savings accounts, especially the young and the breeding females, are slaughtered to survive the winter. You can't bounce back easily from that. You've eaten your insurance policy. At the regional scale, something similar is happening. States like the Eastern Roman Empire maintained granaries in key cities. Think of these as strategic buffers: a failed Nile flood. Draw down Alexandrian stores, ship grain to Constantinople, adjust the tax records, hope next year is better. But when multiple breadbaskets are hit at once, Egypt, North Africa, parts of Anatolia and the Levant all getting colder, shorter growing seasons, the math changes. There is no easy somewhere else you can tap. If the Nile's crop is down and Anatolia's barley is stunted, and Sicily's yields are off, the surplus that powered the system starts to evaporate. And this is where geography becomes destiny. Marginal farmers and frontier regions suffer first and hardest. If you're farming deep, rich alluvial soils on a big imperial estate near a port, with irrigation or river access, you have options. Your landlord has reserves. Officials notice your region's problems because it matters for tax revenue. Grain ships still call at your harbour even if they're a bit emptier. But if you're scraping a living on a hillside at the edge of cultivation, relying on rain that's now coming late mixed with frost and unseasonal storms, you're exposed. Your soils are thin. Your yields in a good year are barely enough. A string of bad years pushes you over the edge quickly. Borderlands, uplands, and high latitudes feel the pinch faster. Harvests there are already short and weather sensitive. Add a couple of cold, cloudy summers, and your growing season shrinks below the minimum needed to ripen certain crops. Barley that once barely made it to maturity now dies green. Fruit trees fail to set. Hay yields drop, and with them, the number of animals you can keep alive through winter. On a map, this looks like a gradient. Central valleys and core provinces hurting but coping, while mountain villages, northern farms and dry margins tip into outright crisis. On the ground, it looks like something more immediate. The poorest selling tools, then animals, then land, then themselves. Markets broadcast this crisis in a language everyone understands: price. Grain prices don't just drift upward, they spike, wobble, and behave erratically. Contemporary writers mention wheat and other staples suddenly selling for many times their usual rate in Mediterranean cities. We can't always trust the exact ratios. Chroniclers loved dramatic numbers. But the trend is clear. Scarcity pushes prices up, and uncertainty keeps them there. If you have money or connections, you can navigate this at least at first. You buy in bulk early, you quietly fill your warehouses when the first signs of trouble appear. You hold onto your stocks while word spreads that the harvest was poor. Then, when hunger is general, you sell at a profit, or you don't sell at all unless someone meets your price. Hoarding isn't just a moral failing in this context, it's a rational response to a world where you suddenly cannot trust that next year will be better. Merchants and landlords hoard because they fear running out. Families hide food from neighbours and officials for the same reason. In the shadows of this fear, black markets thrive. Officially, a ruler might try to cap prices, forbid exports, or order granaries opened. On paper, that looks like decisive action. In reality, sellers drift to less regulated spaces. Grain moves at night through side gates and secondary harbours. Soldiers, tax collectors and local elites take cuts. Smuggling becomes a survival strategy for both hungry buyers and cautious sellers. And as always, when resources are limited, access is unequal. Urban notables, military garrisons and religious institutions often get priority. If you're attached to a monastery, a big estate, or a wealthy household, your odds improve. If you're a landless labourer or a tenant with no leverage, you're at the end of the line. By the time grain filters down to you, if it does at all, the price can be so high that you're trading away long-term security for a few weeks of life. This is where hunger stops being just an economic fact and starts reshaping bodies. Chronic undernourishment, even short of outright starvation, does terrible things. Children stop growing properly. Wounds heal slowly. Vulnerability to every other stress, cold, exhaustion, infection, skyrockets. A minor illness that would have been annoying in fat times becomes lethal when your reserves are gone. On a population level, this shows up as higher mortality and lower fertility. Women who are severely underfed may stop menstruating. Pregnancies become riskier. Infants born into these conditions are smaller, weaker, more likely to die in their first year. Old people and the already sick go first. Then, increasingly so, do the young. And there's a darker feedback loop here that history keeps repeating. Malnutrition makes you more likely to catch and die from disease. Famine years are often followed or overlapped by epidemics, not just because pathogens suddenly appear, but because the hosts are weakened. The immune system is a luxury that runs on calories and protein. Take those away, and you've primed entire populations for the next microbial hit. Politically and socially, hunger is corrosive. Food shortage is not a distant statistic when you're living through it. It's a daily negotiation with fear. Parents go to bed listening to their children cry from emptiness. Neighbours start watching each other's doors. Rumours spread about hidden grain, about unfair distributions, about officials favouring their own. Under those conditions, trust collapses fast. Allegiances that seemed solid in prosperous years, between tenant and landlord, soldier and commander, subject and emperor, start to fray. Why keep paying taxes if the state can't protect you from starvation? Why respect a lord who still eats well while your family wastes away? Why obey market rules when black market bread is the only thing standing between you and death? Hunger also moves people. When local options have been exhausted, migration becomes the last gamble. Families abandon marginal farms and head towards cities, ports, religious centres, anywhere rumours say food might still be available. Border regions empty out. Some groups cross frontiers, seeking relief in neighbouring polities. Others drift into banditry, raiding stores and convoys, because there is simply nothing left to lose. From the viewpoint of rulers, these are not abstract tragedies, they are security threats. Hungry soldiers mutiny. Starving urban crowds riot. Tax bases shrink as villages are deserted. Whole stretches of frontier become unguarded as communities that once supported garrisons disappear. In the quiet language of administrative documents, you sometimes see this as a simple note. Land uncultivated, village deserted, population diminished. Behind each phrase is the same story. Harvests that failed, prices that soared, bodies that weakened, and a social order that discovered just how much of its stability had rested on the assumption that the sun would rise, the seasons would behave, and there would be enough to eat. In the mid-530s that assumption shattered, and in the regions most tied into the Roman Mediterranean world, the strain on food supplies was about to collide with another set of pressures, fiscal, military and political, that were already pushing the late antique system toward its limits. If you zoom out from the level of the hungry village and look at the 6th century Mediterranean as a whole, you don't see a peaceful world suddenly blindsided by climate. You see a system that was already running hot. Take the Eastern Roman Empire ruled from Constantinople. On paper, it was the great survivor of antiquity, Roman law, Roman bureaucracy, Roman tax system, Roman armies. But by the 530s, all of those strengths came with heavy costs. The state was at war, not a little border skirmish, but big prestige projects. Justiniani's government had just fought a grueling war with the Persians in the east, buying a fragile eternal peace with a massive gold subsidy. Almost immediately he launched the reconquest of the old western provinces. Armies were in North Africa, then in Italy, chewing through men, money and supplies. Armies run on grain even more than on gold. Every campaign meant requisitioning carts, animals and food from already strained provinces. Egypt, the classic breadbasket, was squeezed for Annona shipments to Constantinople. North Africa, freshly reconquered, was expected to both feed its garrisons and send surplus across the sea. Sicily, southern Italy, and parts of the Balkans were pulled into the same provisioning web. Now layer the darkened skies of 536 over that. Those bad harvests we just talked about didn't hit a blank slate. They landed on top of war taxes, forced levies, emergency requisitions. When the Nile flood underperformed or an Anatolian barley crop failed, imperial officials didn't simply shrug and lower expectations. They often pushed harder from the state's perspective. There were non-negotiables. The capital had to eat. The army had to be paid and supplied. Diplomatic bribes to Persia had to be maintained, or the eastern frontier would erupt again. So when harvests shrank, the imperial administration tried to protect these core obligations by shifting the pain downward. Tax in kind, grain, oil, wine, was assessed based on older, better years. In a string of bad years, that arithmetic turned vicious. Peasants watched assessors demand quotas that now represented not surplus, but survival rations. Local elites who acted as intermediaries were trapped between imperial expectations and the anger of their own communities. In a wealthy Nile village with irrigation and deep soils, People might grumble but still scrape together enough to meet demands. In a marginal district of inland North Africa where rains had failed, the same tax rate could be lethal. The result is a patchwork of outcomes across the Mediterranean. In Egypt, some papyri hint at villages petitioning for tax relief, claiming floods were low, harvests meagre, lands ruined. Sometimes they got temporary reductions or postponements. A canny governor or a well-connected local notable could bend the rules, giving communities a bit of breathing room. Other times the system was less forgiving. Arrears piled up and tax debts were converted into long-term obligations, binding families more tightly to estates and tax rolls. In Italy, the picture was even more chaotic. The Gothic War turned whole regions into battlefields. Fields went untilled because men were under arms or had fled. Cities like Rome, already dependent on imported grain, saw their supply lines cut or disrupted. A cold, dim summer in the countryside translated into real hunger in besieged urban centres months later. Some cities weathered this better than others. Ravenna, closer to supply routes and political power, had options. Rome, with its iconic weight but weakened economic base, was more exposed. Local bishops stepped into the gap in some areas, organising relief, opening church granaries, redistributing wealth. In others, military commanders simply took what they needed, because their first responsibility was to keep their troops alive. Further west in Visigothic Spain or Vandal North Africa before Justinian's conquest, we see different patterns. These kingdoms lacked the same dense fiscal machinery as Constantinople, which could be a curse or a blessing. On one hand, the state had fewer levers to move grain across long distances or to maintain big public granaries. On the other, peasants might be spared the full extraction power of a Roman-style tax apparatus during bad years. A drought in Baetica or Mauritania could still be devastating, but its social impact might unfold more through local negotiations and less through imperial decrees. Leadership choices mattered enormously in these years. A ruler who recognized that this was not just another bad harvest, but a sustained shock, could choose to ease tax burdens, suspend arrears, prioritize feeding civilians over funding vanity projects. There are hints that some did. Periodic tax remissions, remapping of fiscal districts, orders to protect seed grain. These show up in scattered legal texts and letters, but decisions could also cut the other way. An emperor convinced that victory in Italy was essential for his legacy might double down on military spending precisely when the economy needed relief. Local governors trying to impress the capital might over-report what their districts could pay, then squeeze their populations to hit impossible targets. Religious building campaigns, while spiritually meaningful, could divert labour and resources from agriculture at exactly the wrong time. And always there was the problem of information. In a world without instant communication, central authorities often learned about disasters late, filtered through the interests of local elites. By the time accurate reports of multiple failed harvests reached Constantinople, notices had to travel back out, and another season might already be in the ground. Misjudged timing turned some well-intentioned policies into blunt instruments. Meanwhile, unrest simmered. High prices and hunger in cities translated quickly into riots, especially when rumours spread that officials were hoarding or exporting grain. Soldiers who missed pay because tax shipments were delayed might mutiny, turn to extortion, or simply desert. In countryside districts, bands of displaced peasants could be labelled brigands in official records, another tidy word for people whose farms had failed and who now survived by raiding. The Mediterranean of the late 530s was not collapsing everywhere at once. Some regions bent and then recovered, others fractured. The same climate signal, colder summers, worse harvests, played very differently in Constantinople's bureaucratic heartland, in a war-torn Italian valley, in a Nile village under a pragmatic governor, or in a highland community at the edge of any state's reach. But everywhere the margins of safety were shrinking. By the time the skies began to brighten a little, many communities were carrying invisible scars, depleted herds, exhausted soils, broken credit networks, populations thinned by hunger and flight. The imperial treasury was strained by war and relief, yet still expected to perform miracles. Trust in institutions had been eroded by the hard arithmetic of extraction and survival. And into this already weakened, nutritionally stressed world where bodies were lighter, immune systems compromised, and people crowded into besieged cities and refugee camps, something new began to move along the same trade routes that once carried grain and gold: disease. It didn't announce itself with trumpets. In the early 5040s, people around the Mediterranean started noticing small local horrors. A ship's crew dying in port, a neighbourhood in Alexandria suddenly quiet, a village where the bells rang for the dead a little too often. Our main literary voice for what came next is Procopius, a lawyer-turned-historian in Constantinople. He tells us that in the spring of 542, a strange disease appeared in the capital. At first it seemed like any other fever. People felt tired, light-headed, maybe had a headache. Then, within a day or two, something new: swellings in the groin, armpits or neck, buboes, painful, inflamed lymph nodes, sometimes the size of an egg, sometimes larger. Some people went delirious, raving or falling into deep stupor. Others stayed clear-headed, but watched in terror as their bodies betrayed them. Procopius claims that in the worst weeks, thousands died each day in Constantinople alone. Bodies piled up faster than they could be buried. Officials ran out of graveyards and began tossing corpses into hastily dug trenches, then into abandoned towers along the city walls. Modern microbiology gives that description a name: bubonic plague, caused by the bacterium Yersinia pestis. It's the same pathogen that would later fuel the Black Death in the 14th century. DNA from Yersinia pestis has been extracted from remains dated to this era in Western Europe, confirming that some form of plague really was circulating around the time Procopius is describing. What we don't have is a neat cinematic origin story. On this day, in this place, the plague began. The written sources hint at Egypt as a starting point. Grain ships from the Nile sailed into Constantinople just before the outbreak there, and later writers imagine infected rats travelling with them, fleas jumping from one host to another as easily as the grain itself moved from hold to warehouse. The basic mechanism, as far as we understand it today, is simple and brutal. In its classic form, bubonic plague is a disease of rodents and their fleas. The bacterium circulates within rodent populations, often wild species like gerbils or ground squirrels, not just the black rats that later get all the blame. Fleas drink the blood of infected animals, the bacteria multiply inside them, sometimes clogging their guts, and when those fleas bite new hosts, they inject the infection forward. Most of the time, this is a local ecological drama. Rodent populations swell, disease rips through them, numbers crash, and things settle into a new balance. Humans might never notice, but climate throws gasoline on that system. Rodent numbers are tightly linked to food availability. A run of good years, mild winters, decent rainfall, plenty of seeds and vegetation can trigger rodent booms. Burrows fill, colonies expand. More rodents mean more fleas. More fleas mean more opportunities for a pathogen like Yersinia pestis to establish itself and circulate at high levels. On the other hand, environmental shocks can drive those same rodents out of their usual refuges. Droughts, failed harvests, or cold summers can strip wild landscapes of food. Hungry animals don't respect boundaries. They invade fields, barns, granaries, exactly the places where humans are concentrating their own dwindling supplies. Now picture the 530s and 540s in that light. We have evidence for climate volatility, Years of unusual cold after 536 disrupted rainfall patterns in different regions and the knock-on effects on crops and pastures. We have stressed humans crowding into cities, refugee clusters, besieged towns, all sharing cramped, unhygienic spaces where rats could thrive on spilled grain and garbage. We have intensifying long-distance trade networks pushing grain, tax revenues and military supplies across the eastern Mediterranean on tight schedules. In that kind of world, the invisible frontier between wild rodents and human spaces blurs. Do we have a smoking gun connecting a particular volcanic winter to a particular plague spillover from animals to humans? No, that's where we move from hard evidence to hypothesis. The evidence side looks like this. By the early 540s, plague is clearly present in key nodes of the Mediterranean world. Literary sources describe outbreaks in Egypt, Constantinople, Palestine, Syria, North Africa and Italy. Over the next few years and decades, other texts mention disease waves reaching as far as Gaul, the British Isles, and possibly Persia. Archaeological DNA now backs up that narrative, showing Yersinia pestis strains appearing in 6th century graves in Europe. Writers report terrifying mortality. Procopius uses round, dramatic numbers, tens of thousands dead, houses emptied. Another contemporary, John of Ephesus, tells stories of towns where the living couldn't bury the dead, where shepherds' flocks wandered ownerless. Later chroniclers turn the plague into something almost apocalyptic, a punishment from God that swept away multitudes. Modern historians are more cautious. Those numbers are almost certainly exaggerated. Cities rarely keep functioning if a third or half of their people drop dead in a single season. But even if we scale the figures way down, the disruption is obvious. Courts stop meeting, tax collection falters, armies delay campaigns. Laws are issued about inheritance, orphan care and debt because so many families have lost key members. What we don't have is a direct line on a graph that says 536 eruption, colder summers, rodent response, plague emergence. That's the hypothesized causal chain, built from ecological models and analogies with later pandemics. There's a plausible story here. Cold, dim summers and erratic rains don't just hurt wheat and barley. They ripple through entire ecosystems. In Central Asia, where some plague reservoirs have existed for millennia, small changes in temperature and moisture can dramatically alter rodent breeding cycles. Similar dynamics show up in East Africa and other regions with long-term plague reservoirs today. Human pressure, expanding agriculture, new trade routes, military campaigns, then brings people, livestock and grain stores into closer contact with those shifting wild populations. Layer on top of that what we already traced in the last section, famine and displacement. Hunger weakens immune systems. People short on calories and micronutrients are more vulnerable to infections and less able to fight them off. Displaced people, refugees from war, drought or tax pressure, clustering camps, city slums and fortified towns. Sanitation breaks down. Water is shared. Air is shared. Vermin are shared. An infection that might have burned out in a sparsely populated countryside can, in these conditions, rip through densely packed neighbourhoods. And famine doesn't just create more victims, it creates more vectors. Grain is stored in emergency warehouses on ships in hastily converted buildings. Rats and other rodents move in. Fleas proliferate. Each sack of grain moved from a rural storage pit to an urban depot becomes a potential bridge for infected rodents and their parasites. So by the time plague appears in the record in the 5040s, it's not stepping into a healthy, well-fed, widely dispersed population. It's entering a world where many people have recently endured bad harvests, high prices, forced relocations and war. A world where social safety nets are frayed and political authorities are already struggling to keep up. This is what turns the Plague of Justinian from a terrible disease into a compounding disaster. Even if you set aside any direct climate-to-plague causation, the timing is brutal. The Eastern Empire is in the middle of costly wars in Italy. Tax arrears are accumulating. Some regions are still recovering from the climatic shocks of the previous decade. Then suddenly, in 542, the capital itself is hit. Procopius describes Justinian falling ill, hovering near death. Courts shut down. Diplomacy stalls. Administrators either die, flee, or become paralyzed with indecision. Ports are infected. Trade slows, not just because of fear, but because there are fewer sailors, fewer dock workers, fewer pack animal drivers. The same routes that had carried grain and soldiers now carry fleas and pathogens. Mortality among skilled workers hits infrastructure hard. Bakers, millers, muleteers, scribes, tax clerks, shipwrights, these aren't interchangeable peasants in the eyes of the administration. Losing them means it takes longer to collect grain, longer to process it, longer to transport it to where it's needed. Delays translate into shortages. Shortages feed unrest. Unrest demands military responses which require still more grain and money from an economy that's already sputtering. In the countryside, plague can be more selective. Some villages might escape almost untouched, others might lose half their households. But the psychological effect spreads regardless. Stories of whole families wiped out travel faster than the disease itself. People abandon sick relatives out of fear. Others crowd into churches and shrines, seeking divine protection and, in the process, creating perfect conditions for further contagion. We should be clear about uncertainty. Did the volcanic events of 536 and after directly cause the first Great Plague pandemic? We don't know. The safest statement is that they likely helped shape a more fragile, interconnected environment and society, one in which a pathogen that might have remained a local zoonosis instead became a Mediterranean-wide catastrophe. What we can say with more confidence is that by the time plague arrived, the system had very little slack left. Climate shocks had already narrowed margins of safety. War and taxation had already thinned reserves of grain, money, and trust. Famine, flight, and crowding had laid out the dry tinder. The Plague of Justinian was the spark that landed in it. From that point on, the story of the 6th century is not simply a tale of bad weather or of disease, but of how those forces interacted, how a darkened sky, empty granaries, and infected fleas together reshaped the human landscape of Eurasia. And in the lands far from Constantinople, where Roman tax collectors never came but oral traditions did, people were also trying to make sense of dark summers, hard winters, and waves of death. In some of those places, the memories would eventually turn into myths of a world plunged into a long, killing winter. Centuries after the sky dimmed, when nobody remembered the names of the emperors who had ruled in Constantinople, poets in the north told a story. They called it Fimbulwinter, the mighty winter, a time when snow fell in every direction, winds howled, summers never really came, and the world staggered toward its end. In later written versions of Norse myth, Fimbulwinter is the prelude to Ragnarok, the final battle of gods and giants. It's not just cold, it's failed crops, broken bonds and desperation. Brothers killing brothers, parents and children turning on each other. Society, quite literally, freezing and shattering. Now here's where historians perk up, because around 536 we have independent evidence for a different kind of winter. Not one myth, but tree rings from Scandinavia, Ireland, and the Baltic that suddenly narrow. Growth collapses. We have ice cores from Greenland showing sulfate spikes and volcanic ash. We have written sources further south describing dim suns, dry fogs, failed harvests. So people ask, is Fimbulwinter a cultural echo of that real climatic shock? It's a tempting thought, almost too tempting. On the one hand, oral traditions can preserve surprisingly old memories. Stories of floods, strange stars, or years without summer can pass down for centuries, getting reshaped and mythologized along the way. The details turn supernatural, but the emotional core, fear, hunger, the sense that the world itself has turned hostile, can survive. On the other hand, myth is not a documentary. It's not a weather report. By the time the Fimbulwinter stories were written down in medieval Iceland, more than 600 years had passed since 536. In between, Northern Europe had seen other cold snaps, famines and wars. Any specific memory would have been marinated in later crises, reinterpreted in Christian frameworks, reworked by poets with their own agendas. So historians tread carefully. Instead of saying Fimbulwinter equals 536, they ask a softer question. Could myths of a long, killing winter reflect a recurring pattern of hardship, of which the volcanic dimming of the 530s was a particularly brutal example? To answer that, we have to step out of the sagas and into the soil. Archaeology gives us a different kind of memory. Not stories, but patterns. In the 530s and 54s, across parts of Scandinavia and the North Sea world, something odd happens. Settlements shrink, shift, or vanish. Long-occupied farmsteads are abandoned. In some regions, like parts of Sweden and Norway, you see what researchers call the deserted farms phenomenon. Dozens, sometimes hundreds of previously used sites go quiet. At the same time, you start getting hoards. People bury valuables, gold, silver, finely worked ornaments, in bogs, lakes, or the ground. Some of these deposits predate 536. Others cluster suspiciously close to the mid-6th century. Interpreting hoards is tricky. They can be ritual offerings to gods. They can be emergency stashes hidden in war. They can be elite showpieces dedicated in times of stress to secure favour from powers unseen. But the fact that we see increased hoarding alongside settlement disruption at least tells us this wasn't business as usual. Then there are the dead. In some northern regions, burial practices change across the 6th century. Grave goods become simpler or rarer in certain areas. Monumental burial mounds appear, or stop appearing, depending on the local tradition. Cremation might give way to inhumation or vice versa. It's not one uniform pattern across all of Northern Europe, but the timing of some of these shifts overlaps with the volcanic downturn. What does that mean? Again, no single grave screams volcanic winter, but taken together, these signals abandoned farms, concentrated hoards, new burial customs suggest social stress. Populations reorganizing, elites losing grip or reinventing their power. Imagine you're a regional chieftain in Scandinavia around 535. Your status depends on predictable harvests, on being able to throw feasts, hand out gifts, sponsor warriors, and maintain a network of dependents who believe you can keep them alive in hard times. Then 2 summers in a row the sun shows up late and weak. Frosts come early. Grass growth stalls. Livestock struggle through thin hay. Grain ripens poorly, if at all. You empty your storerooms to feed followers, but the next year is no better. At first, a strong leader can turn crisis into legitimacy. You tighten control. You redistribute food. You demand loyalty in exchange for survival. But repeat failures cut both ways. If you can't secure grain, if your gift-giving dries up, if your warriors are hungry, your sacred aura cracks. Rivals whisper that the gods have abandoned you. People start walking away. They join neighbouring groups, migrate to new lands, or simply die. Archaeologically, that kind of political unravelling wouldn't look like one dramatic collapse. It would look like a web fraying. Some centres lose importance, others gain it. Some valleys empty out. Hilltops or more defensible sites see new activity. Hoards might be offerings from anxious elites begging divine help, or caches hidden during raids in a newly unstable landscape. Burials might shift as communities renegotiate their identity and beliefs under pressure. And in the stories that survivors tell their grandchildren, these years don't become a chapter on mid-6th century volcanism. They become the time when winters grew unending, when kin turned on kin, when the old ways failed and the world teetered on the edge. That's how a climatic shock can become a mythic winter of the gods. At the same time, we have to keep the picture balanced. Northern Europe in the 530s and 540s was not a blank slate afterward. It didn't empty out to zero. In many places, life went on. Some regions show continuity of settlement, stable burial traditions, and even signs of ongoing trade. The hoards themselves, full of beautifully worked gold and imported objects, prove that elites still had access to wealth and long-distance networks, at least for a while. The story isn't civilization vanished in the north. It's certain social arrangements became more fragile. Repeated bad harvests squeeze the middle of society. Small farmers go under or fall into dependence. Local chiefs either centralize power, using crisis to break rivals, or they fragment as followers drift to stronger neighbors. Traditional cults might lose credibility. New religious practices or political leaders step into the gap. Over generations, those transformations become the seedbed for later changes. The rise of new kingdoms, new identities, new law codes. The sagas and myths we eventually read are products of that long reordering, not eyewitness diaries from 536. So, when we listen to stories of Fimbulwinter, we're not hearing a straightforward report of a single volcanic event. We're hearing an echo chamber. Waves of hardship, some caused by distant eruptions, others by local politics, wars, or ordinary bad luck, bounce around in memory. They blend, they grow teeth and claws. The cold becomes a monster. Hunger becomes a prophecy. Social breakdown becomes the end of the world. And behind those stories, faint but still visible in the archaeological record, we can glimpse the real people of Northern Europe in the 6th century. Farming, burying, migrating, hoarding, losing some worlds, building others. Not passive victims of a darkened sun, but communities trying to improvise a future when the old rhythms of seasons and power no longer felt reliable. While skalds in the north turned crisis into myth, scribes in the east and officials in the great states of Asia were doing something different. They were writing it down. Their records give us another angle on these strange years, monsoons that failed, snow in summer, and rulers scrambling to act when the sky itself seemed to have changed. In China, in Korea, in the courts of Japan, people were also living through those same dim years. But unlike the poets of the north, they had bureaucrats. For centuries already, Chinese dynasties had trained officials to watch the heavens and record what they saw. Eclipses, comets, halos around the moon, strange fogs, rain that came at the wrong time, or not at all. These weren't just curiosities. They were political data, because in the Chinese political imagination, the weather was part of the job description of an emperor. If the monsoon came on time, if the rivers behaved, if harvests were good, it meant heaven approved of the ruler. If the sky went strange, drought, flood, frost in summer that could be read as a warning, a sign that the mandate of heaven was slipping. So when the climate lurched in the 53s, state scribes were ready, brush in hand. In the official histories of the Northern Way, Eastern Way, and their successor regimes, you start to see clusters of extremely odd entries right around the mid-6th century. Reports of yellow dust dimming the sky, of frost and snow in the 6th month, of harvests that fail across multiple provinces at once. Later compilations like the Book of Zhou and the Book of Sui look back and describe a series of disaster years when famine spread and refugees wandered in search of food. The exact phrasing varies. The dates wobble by a year or two depending on the calendar system. But the pattern is unmistakable. Multiple years of abnormal cold and disrupted rains. On the Korean peninsula, the Samguk Sagi, a 12th century history of the Three Kingdoms period, preserves earlier annals from the 6th century. There too we find notes of severe frost in summer, of great cold that harmed the crops, of people dying on the roads during famine. In Japan, the earliest chronicles, like the Nihon Shoki, were compiled later, but incorporate older court records and oral traditions. They mention years of very poor harvests, sudden cold snaps, and unusual celestial phenomena in the same broad window. None of these texts say a volcano erupted on the other side of the world. They don't have that vocabulary. What they do give us is a chorus of voices from different corners of Asia, saying essentially the same thing. The seasons went off script. To understand why Asia, and especially East Asia, was so sensitive to this, we have to talk about the monsoon. The Asian monsoon system is one of the most powerful pieces of Earth's climate machinery. Every year, as the landmass of India and China bakes in the summer sun, it heats up faster than the surrounding oceans. Hot air rises over the continents, drawing in moist air from the seas. That air rises, cools, dumps rain. Whole civilizations depend on this rhythm. Now imagine you suddenly throw a veil of volcanic aerosols into the stratosphere. Those tiny sulfuric acid droplets reflect sunlight back into space. They don't block light evenly. Land tends to cool faster than ocean. The temperature gradient between continent and sea, the very engine of the monsoon, weakens or flips. In some regions, that means the summer monsoon fails. Rains arrive late, sputter, or don't reach as far inland. In others, the altered wind patterns can actually intensify rainfall or shift it into the wrong season, turning ordinary flows into destructive floods. This is why volcanic eruptions can produce what looks, from the ground, like climate schizophrenia. Global averages go down, cold summers show up in tree rings from Ireland to Siberia, but locally you might get severe drought, catastrophic flood, or both in rapid succession. In parts of northern China during the 53s, sources talk about the fields cracking from dryness, followed not long after by waters covering the land as major rivers flooded. Grain rotted in low-lying paddies, dry land crops withered. The usual fallback options failed because the extremes were hitting different regions at once. Modern climate models, when they simulate a very large tropical or high-latitude volcanic eruption, reproduce this exact kind of pattern over Asia: a weakened East Asian summer monsoon, a southward shift of rain belts, and increased odds of both drought in the north and flooding further south and east. That lines up almost unnervingly well with what the scribes were seeing. And because these were states with working administrations, we can actually trace not just the weather but the response. Take the Northern Wei and the dynasties that followed in northern China. By the 6th century, they had inherited centuries of practice in famine management from earlier empires. They had state granaries, warehouses where surplus grain was stored in good years, specifically to be released in bad ones. They had established grain transport routes along rivers and canals. They had laws for tax remissions and labour exemptions when disaster struck. So when monsoon failure and cold summers hit, officials didn't just shrug. They wrote memorials to the throne. Some of those memorials, preserved in later histories, are brutally direct. They describe hundreds of miles with no sound of cock or dog, a formula for depopulated countryside. They warn that if relief is not swift, the people will scatter. They recommend opening granaries, suspending corvée labour, sending inspectors to prevent local magistrates from hoarding or profiteering. At the same time, rulers worried about control. Famines don't just kill. They move people. As crops failed, peasants and tenant farmers left home in search of food or more reliable landlords. Bands of hungry refugees could turn into bandits or mercenary forces for rival claimants to the throne. So we see edicts that try to manage migration. Orders to register displaced families, to send them back, or to resettle them in underpopulated areas where the state needed labour and taxpayers. In the south, under the Liang dynasty, we see similar patterns. Reports of cold harming the rice, of locust outbreaks taking advantage of weakened crops, of the court ordering the distribution of stored grain and the reduction of palace expenditures in sympathy with the people. Sometimes these efforts worked well enough. Regions with good infrastructure and strong local administration could buffer a year or two of bad harvests. The ancient granary system, for all its flaws, was a kind of analogue shock absorber in a pre-industrial world. But a volcanic climate shock doesn't respect administrative boundaries. If multiple provinces are hit at once, if several years string together with poor yields, even the best-run granary network starts to strain. Grain prices spike, corruption creeps in, local elites hoard resources. Military governors with access to food and soldiers start to look more attractive than distant emperors. And right on cue, the mid-6th century in China is politically messy. Northern dynasties fracture and reunify. Rebellions flare in famine-stricken regions. The Liang in the south face internal revolts and external pressure. Climate is never the only cause of instability, but in this period it's a powerful multiplier, turning existing tensions over land, taxation, and ethnic divisions into open conflict. Zooming out from East Asia, the same decade shows signs of strain across the wider monsoon world. In South Asia, later texts and inscriptions aren't as neatly dated, but references to great scarcity, years of want, and temples feeding crowds cluster around the same broad window. In Central Asia, some archaeological sites show abrupt contraction in the 6th century, with irrigation works silted up and caravan routes shifting. Put all this beside the evidence we've already seen. Tree rings from Europe and Siberia tightening at the same time. Ice cores in Greenland and Antarctica showing matching sulfate spikes. Written testimonies from the Mediterranean about dim suns and poor harvests. Legends in the north of winters that never ended. And now, bureaucratic records from Asia of monsoon chaos, snow in summer, and states struggling to contain famine and migration. Each one on its own could be local bad luck, a regional cold snap, a political exaggeration. Together they look like something else, a hemispheric event, or more likely a cluster of eruptions, powerful enough to tug at the very machinery of climate from the Atlantic to the Pacific. And as always, the story is double. On the one hand, we see terrifying vulnerability. One or two big bursts of volcanic sulfur can shatter harvests, ignite famines and push already fragile polities toward crisis from Constantinople to Luoyang. On the other hand, we see systems that bend rather than instantly break. Granaries are opened, taxes are remitted, refugees are monitored and resettled. New power structures emerge from the turmoil. Asia's chronicles don't just tell us that the sky went wrong. They show us how complex societies tried to live with that wrongness, how they deployed storage, bureaucracy and coercion to ride out a climate roller coaster they didn't understand. But even those tools had limits. To see how far the shock of the 530s rippled along the trade arteries that connected Asia, Africa and the Mediterranean, we have to follow the monsoon winds and caravan routes, south and west, into the markets of Arabia, the Nile Valley, and the kingdoms beyond the Sahara. Follow those caravan routes south and west, and you very quickly run into a different kind of climate logic. If East Asia lives and dies by the monsoon, the Middle East, and much of Africa live and die by belts of rain that slide north and south with the seasons like a breathing planet, most of North Africa and Arabia are dry, not because the sky can't make rain, but because the main band of tropical thunderstorms, the intertropical convergence zone, usually hangs too far south. Once a year in boreal summer, it creeps north. The Nile floods. The Sahel greens pastures appear where, a few months before, there was only dust. Shift that belt even a little, and the consequences ripple from goat herds to gold caravans. Volcanic aerosols in the stratosphere don't just cool things down. They change temperature contrasts between land and sea, tweak wind patterns, and with them the position and strength of these rain belts. Climate models that simulate a big 6th century eruption show just this. The African monsoon weakening or stalling further south than usual. The Mediterranean storm tracks shifting, some zones getting deluged while others dry out. From the ground, it doesn't look like a neat global pattern. It looks like a patchwork. Picture the eastern Mediterranean coast in the 53s. Chroniclers in Palestine and Syria talk about years without proper rain, about withered vines and empty cisterns. A weakened winter storm track could easily do that. Less rain reaching the Levant, more drought stress on already marginal dry farming systems. Barley fails on the uplands, olives don't fruit, hillside villages thin out as people drift toward towns where grain shipments still arrive, for now, from Egypt. Now follow the Nile upstream. The entire logic of the Nile Valley rests on one simple miracle. Rain that falls 1,000 kilometers away in the Ethiopian highlands, then rolls downriver as a predictable summer flood. That flood spreads silt, waters the fields and gives the pharaohs Byzantine emperors. In this period, their tax base. Interrupt the East African rains, and the Nile fails low. Not necessarily every year, not necessarily in dramatic biblical style, but an extra string of poor floods in the 530s. That would track with what we know about volcanic forcing and African rain belts. Later Arabic sources remember a handful of years of scarcity in pre-Islamic Arabia and the Red Sea corridor. Coptic and Greek papyri from Egypt in the same broad window talk about famine, about villages owing taxes they can't pay, about the state ordering remissions and emergency distributions. None of them footnote a volcano. But the timing, again, is suspiciously close. Crucially, not everyone in this belt lived the same way. On the steppe margins of Syria, Jordan, and northern Arabia, pastoralist tribes watched the same clouds with very different hopes than their farming neighbours. They needed just enough rain to bring up grass and fill water holes, not a controlled river flood to irrigate wheat. If the main rain belt shifted south, cereal farmers in Syria might see their fields fail, while some desert grazing lands briefly did okay. A cool, dusty atmosphere might even lower heat stress on animals. For a year or two at least, nomadic herders might be relatively less hard hit than the orchard owners and village peasants tied to fixed plots. That imbalance shows up in politics. 6th century sources from the Eastern Roman and Sasanian frontiers complain about Saracen tribes raiding deeper than usual into settled lands. Arab foederati, tribes allied to the empire, are paid stipends of grain and gold to guard the limes, the frontier. When the empire's own harvests falter, those stipends get less reliable. Loyalty wobbles. If you're a tribal leader whose flocks are under pressure and whose imperial paydays are delayed, the line between border guard and raider gets very thin. Food shortages don't just starve people in place, they make them move. Desert and steppe zones are already hypermobile societies. A bad season means push a few days farther to the next well, maybe bargain pasture access from a rival clan. A bad decade compounded by volcanic tweaked rain patterns can turn routine flexibility into large-scale migration. Push that logic further south. Across the Sahel, the band from modern Senegal through Mali, Niger, Chad to Sudan, farming and herding interlock like the teeth of a gear. Farmers depend on a narrow rainy season to grow millet and sorghum. Herders move cattle and camels between wet season and dry season pastures, often cutting deals with farmers for grazing on crop stubble. A small southward shift in the rain belt can mean, for some regions, repeated failures of the northernmost farms, while areas a bit closer to the equator actually get more water than usual, or rain arriving at the wrong time. Crops drown in fields, others never sprout. We don't have written chronicles from most Sahelian societies of the 30s. What we do have are hints, occupation layers that thin or stop in certain sites, pollen records suggesting vegetation changes, lake levels fluctuating. They don't spell out a neat story, but they're consistent with a world where some communities are suddenly stressed, others unexpectedly favoured. And running right through this climate jigsaw are the trade routes. By the 6th century, the Red Sea and Indian Ocean were threaded by ships hauling grain, wine, textiles, spices, ivory, and enslaved people between Egypt, Aksum, southern Arabia, India, and beyond. Inland camel caravans carried frankincense and myrrh north from Yemen, gold and slaves across the Sahara from the Niger Bend and Lake Chad to the Mediterranean. In theory, these routes could act as lifelines in a bad year. If the Nile floods low but India's monsoon holds up, grain can, in principle, be shipped from the Indian Ocean world into the Red Sea, then up to famine-stricken Egypt. If Syria's dry farming zone fails but the Yemeni highlands get good rain, Arabian merchants might make windfall profits freighting South Arabian surplus north. There are tantalizing signs of this kind of buffering. Archaeologists find 6th century Indian and African goods in ports along the Red Sea. The kingdom of Aksum in Ethiopia is still minting gold coins and involved in wars in South Arabia. Byzantine diplomacy in this period runs through these same maritime corridors, trying to enlist Christian Aksum against the Sasanian-backed rulers of Yemen. At the same time, those same arteries can spread trouble. If a volcanic climate shock helps trigger food shortages in one hub, say, a run of poor Nile floods in Egypt, grain prices spike not only in Alexandria, but along every port that normally buys Egyptian surplus. Merchants with good information gain power. Ports that can still provision ships become strategic prizes. Cities that can't secure food lose population fast. And hovering over all of this is disease. Remember the Plague of Justinian, which will erupt out of the eastern Mediterranean in the 5040s. The black rat travels well on grain ships and caravan wagons. Any system that is moving food across increasingly long distances to patch over local shortages is also unintentionally building a highway for pathogens. It's very likely that some of the same routes that cushioned local famines in the 530s, by redistributing grain, livestock and people, also set the stage for bubonic plague to rip through Red Sea ports, Nile towns and inland markets a decade later. What makes the Middle East and African story so slippery is precisely this unevenness. There is no single moment when the Middle East collapses in 536. Instead, you get mosaics. One oasis prospers because long-distance caravans divert there. Another withers when its well fails and the caravans bypass it. One valley in Yemen gets anomalously good rain and exports grain. Another, just over the ridge, loses its terraced fields to drought and landslides. Some pastoral confederations parlay their relative resilience into more political clout on imperial frontiers. Others break apart under the strain. Even within Egypt, some districts manage the bad years with clever water management and grain loans. Others sink into debt and depopulation. Aksum might weather the climatic side of the storm relatively well, but bleed itself in foreign wars and shifting trade. Seen from high altitude, the volcanic veil of the 530s tugs on the same climate strings across Europe, Asia, the Middle East, and Africa. But down on the ground in each valley and wadi and city, the tune comes out differently, sometimes as catastrophe, sometimes as opportunity, more often as an exhausting, grinding struggle to adjust. And that messy, uneven reality is exactly what we have to understand when we talk about civilization nearly vanishing. Because what happens next in the decades after 536 isn't a single crash, but a rebalancing, a slow rearrangement of who has food, who controls the trade routes, and which centers of power make it through the darkness, and which do not. The rearrangement wasn't just political, it was economic down to the roots. Late Antiquity, roughly the world of Justinian, the Sasanian Shahs, post-Roman kings in the West, was already in motion before the sky dimmed. Trade routes were stretching, cities were rising and falling, tax systems were creaking under the weight of wars and administrative overreach. The 6th century shocks didn't invent change. They pressed fast forward on transformations that were already underway. Think about it like this. Imagine a long, slow landslide on a hillside. For years the soil creeps, the rocks shift millimetre by millimetre. Nothing dramatic happens until a heavy rainstorm hits. Suddenly, what was a slow, almost invisible movement turns into a rapid slide. The storm didn't cause the instability, but it triggered everything that had been building. The darkened sun of 536, the bad harvests, the price spikes, the plague, those were the heavy rain on an already unstable slope. In the Roman Mediterranean, the economic ideal had been clear for centuries. A big integrated system feeding big integrated states. Grain from Egypt and North Africa to Constantinople and Rome. Wine and oil sloshing around the coasts. Tax in coin flowing into imperial treasuries, then back out as soldiers' pay and bureaucrats' salaries. By the mid-500s, that ideal was already straining. Frontiers were under pressure. The western provinces had slipped into the hands of Germanic kings who kept some Roman institutions but shrank others. Local elites in Gaul, Spain and Italy still used Latin and Roman law, but their world was more regional, less plugged into the old pan-Mediterranean logistics. Add overlapping shocks, and the strain turns into structural change. Take depopulation. The combination of failed harvests and plague doesn't just lower headcounts. It changes the balance between people and land. When there are fewer peasants and just as many fields, labour becomes scarce, and land, relatively, becomes cheap. In some regions, especially in parts of the former Western Empire, that meant landowners consolidating scattered plots into bigger, more defensible estates. Marginal hillsides and remote villages might be abandoned. Effort and investment flowed into fewer, better protected cores. Archaeologists see this in the way some rural settlements vanish from the record, while villa sites or fortified farmsteads grow. In other places, especially where central authority weakened, it pushed the opposite, peasant communities grabbing more autonomy. If the tax collector stops showing up regularly because the bureaucracy is overloaded, or the roads aren't safe, or the regional office is half empty from plague, you suddenly have more room to arrange land use and labour on your own terms. Either way, the economy is reorganising. You see it in the move toward localism. A world used to importing African amphorae of olive oil to Gaul starts relying more on nearby presses. Long-distance shipwrecks in the Western Mediterranean become rarer after the mid-500s. Local pottery and local production fill in the gap. It's not that trade disappears, it's that the radius of everyday economic life shrinks for many communities. Historians used to tell this story as a straight line, decline and fall. Big Roman markets fragment into petty subsistence bubbles. The lights go out. People forget how to do things. The climate shock of 536 plus the plague seemed like the perfect villains in that narrative. The evidence is messier and more interesting because while some areas really do seem to hollow out, others pivot and adapt. And all of this is happening against a broader climate background that doesn't stop in 540. We're not just talking about a few freak summers. Ice cores, tree rings and glacier advances point to something bigger that some researchers call the Late Antique Little Ice Age, roughly a century or more of cooler, more volatile climate in the Northern Hemisphere, starting around 536 and running into the 600s and even early 700s. Not one long uniform winter, but a pattern. More frequent cold extremes, odd seasons, and climate variability sitting on top of the normal ups and downs. Live through that, and your risk calculations change. States that had budgeted for an occasional bad year now faced clusters of them. Farmers who had tuned their crops and techniques to a certain range of conditions suddenly found that range narrower and less reliable. If you were still trying to run a high overhead, highly centralized tax and supply machine like late Roman Egypt, the margin for error shrank. Yet at the same time, this climate background opened windows for new players. When older centres struggled to keep their elaborate systems going, leaner, more flexible power centres can step into the gaps. In the Eastern Mediterranean, Constantinople survives the shocks, but emerges a different kind of capital. The Justinianic dream of reconquering the old Roman West collides with plague, fiscal strain, and climate-stressed provinces. Over the next century, the empire contracts and hardens. Its economy becomes more regionalised, its tax base smaller but more tightly managed. On its southern and eastern flanks, Arab tribal confederations that had once been clients of Rome and Persia begin to find new footing. Their relative mobility, their ability to operate in marginal environments, and their experience straddling caravan routes all become assets in a world where settled agrarian states have taken hits to population and surplus. By the early 600s, when the Sasanian and Roman empires exhaust each other in brutal wars fought with treasuries and manpower already weakened by a century of climatic and epidemiological shocks, the stage is set for something astonishing: the rapid expansion of new polities from Arabia, carrying Islam and new fiscal and legal systems across the very regions that had once been the beating heart of imperial Rome. Again, cause and effect here are complex. You can't say the late antique Little Ice Age caused the rise of Islam or the 536 eruption toppled empires. Ideas, charismatic leaders, religious movements, and pure contingency all matter. But the material conditions mattered too. In Western Europe, the same long chill and reorganization looked different. Here, post-Roman kingdoms like the Merovingian Franks, and later the Carolingians, build their power not on resurrecting old Mediterranean shipping networks, but on land, labour and tribute from a mostly rural, mostly local economy. They inherit fragments of Roman law and literacy, but their fiscal systems are thinner, their towns smaller, their trade more regional. Over time, though, these very constraints push innovation, estate management, new plough technologies, adjustments in crop regimes, and eventually, centuries later, the stirrings of a very different medieval economy. If you zoom out, what you see between the 500s and 700s is not civilization vanishing, but civilization being rearranged under pressure. Big, integrated, tax-heavy empires struggle to maintain the old scale. Long-distance trade hiccups, reroutes, sometimes contracts. Population drops in some cores, labour becomes more valuable, land use shifts, local power holders, bishops, landlords, tribal chiefs take on functions once handled by imperial bureaucrats. At the same time, new long-distance logics emerge. Islamic trade circuits tying the Indian Ocean to the Mediterranean, Baltic and North Sea routes, slowly knitting together a different northern economy, caravan systems adapting to new political maps. Continuity and collapse sit side by side. A monastery copying Virgil in a half-abandoned Roman town. A Frankish king issuing laws in clumsy Latin, while overseeing very non-Roman forms of lordship. An Arab merchant using Byzantine gold coins in a marketplace that now answers to a caliph, not an emperor. The darkened sky of 536 didn't draw a line between ancient and medieval on its own. But it did help twist the dial. It accelerated existing trends toward regionalization, made labour scarcity and land abundance real in many districts, shook confidence in old institutions, and opened spaces where new powers, new ideas, and new economic patterns could take root. To understand how close civilization came to vanishing, you have to hold both pictures at once: the real brutal losses in population, in connectivity, in state capacity, and the equally real, if quieter, story of adaptation, reorganization, and the birth of new worlds in the shadow of the old. So how close did it actually get? Civilization nearly vanished sounds dramatic, and in some ways it fits the mood of the sources. But if we want to measure it, we have to be precise about what collapse even means. Collapse isn't one thing. It's a bundle of different failures that can overlap or come apart. There's demographic collapse, sheer loss of people. Fewer births, more deaths, communities shrinking or disappearing. That's what plagues and famines hit first. There's state collapse, governments losing their grip, tax systems breaking down, armies unpaid, laws unenforced, forts abandoned, officials improvising or walking away. There's economic collapse, trade routes drying up, markets failing, specialized crafts disappearing because nobody can afford them anymore, or because the networks they depended on are gone. And then there's cultural and institutional collapse. Schools closing, scribes vanishing, religious centers abandoned, languages and literate traditions retreating or transforming into something new. When we say civilization nearly vanished, which of these are we talking about? If you line them up and then look at the 6th and 7th centuries, the picture is jagged. Demography first. The Justinianic plague, hitting in the 540s and recurring for 2 centuries, was probably the biggest single mortality shock. Some modern estimates suggest that in the most heavily affected urban regions of the Eastern Mediterranean and the Middle East, populations may have fallen by a third or more in waves. Not everywhere, not all at once, but enough that cities like Constantinople, Alexandria, Antioch, and key Syrian, Anatolian, and Egyptian centres took massive hits. Add to that the bad harvests in the 530s and 540s, the famines, the local epidemics that love undernourished bodies, and you have real demographic contraction in many cores of the old Roman world. Archaeology backs this up. You see it in cemeteries that suddenly spike in burials over a short window. You see it in abandoned farmsteads, in marginal fields going out of use, in towns that shrink inside their old walls, leaving empty lots where houses used to stand. But globally, this is not a human species bottleneck. This is a regional crisis. Populations in parts of northern Europe, the Arabian Peninsula, East Africa, Central Asia and China were stressed, but they don't show the same across-the-board wipeouts. Some areas even seem to be growing by the late 600s and 700s. State capacity is the next metric. Here the shocks hit unevenly. The Western Roman Empire was already gone before 536. Germanic kingdoms had taken over much of its skeleton. Those kingdoms do not neatly collapse in the year without a summer. The Visigothic kingdom in Spain, the Frankish kingdoms in Gaul, the Ostrogoths in Italy, they all face strain, war and succession crises, but their political story doesn't trace neatly onto a single volcanic event. In the East, the Roman Byzantine state bends but doesn't break. It survives plague, climate variability, and brutal wars with Persia. It loses huge territories in the 7th century to the expanding Islamic Caliphate, but its core institutions, coinage, law, bureaucracy, urban life, keep going in Anatolia and parts of the Balkans. In Persia, the Sasanian state does collapse in the 620s, 6030s, after decades of war with Constantinople and internal turmoil. Climate stress and plague were probably part of that story. Thinner tax bases, disrupted agriculture, exhausted manpower, but the proximate causes are political and military. In China, the northern and southern dynasties are already locked in their own cycles of war and reunification. The 530s, 540s fit into a longer era of instability, not a single sudden break. So at the level of states, what we see is not a synchronized global die-off of government, but a cluster of crises that push some regimes over the edge and force others to transform. Economically, the contractions are easier to see. Mediterranean shipwrecks, a proxy for long-distance trade volume, decline in the later 6th and early 7th centuries. African red slip pottery, a signature export of North Africa, becomes rarer in western and northern sites. Coin hoards and fresh minting patterns show stress and regionalisation. Fine imported ceramics and luxury goods thin out in many rural areas. That looks a lot like economic shrinkage. Less surplus, fewer long-distance exchanges, more local production for local consumption. At the same time, this is not a return to Stone Age barter. In the East, Byzantine gold continues to circulate. In the Islamic world, new silver and gold coinages, new tax systems, and new trade circuits emerge astonishingly quickly. In northwestern Europe, while Mediterranean imports dry up, internal routes along rivers across the North Sea into the Baltic start to hum more by the later 7th and 8th centuries. Culturally, the lights go out narrative also overreaches. Yes, some cities contract, some schools close. Monumental building slows in many regions. The loss of population and resources means fewer big, ornate basilicas, fewer new aqueducts, fewer urban amenities. But scriptoria in monasteries copy and preserve texts. New religious movements explode, Christianity reshaping Europe and the Mediterranean, Islam reshaping the Middle East and North Africa, Buddhism and Confucian traditions adjusting to new political landscapes in Asia. Languages don't vanish, they evolve. Latin fractures into the early Romance tongues. Arabic becomes a new imperial and scholarly language. Greek, Syriac, Coptic, Armenian and others carry learning forward under new regimes. So what about resilience? Where do we see systems bending instead of breaking? We see it in relief and redistribution systems that still function, even at reduced capacity. Byzantine sources describe imperial granaries, emergency shipments of grain, attempts to cap prices during famine. These don't always work, but the fact that they're attempted shows the state is still there, still trying. We see it in trade pivots. When African grain and oil are less reliable, other regions ramp up their own production. When one set of sea routes becomes dangerous or unprofitable, caravans and river routes pick up more of the slack. Islamic merchants tie the Red Sea, the Persian Gulf, and the Indian Ocean together into new circuits. Scandinavian traders later plug into those Islamic markets via the Volga and Dnieper. We see it in technological and social adaptations. Farmers shift crop mixes. They experiment with hardier varieties and different planting regimes. In Northern Europe, heavier ploughs and new field systems gradually change how land is used. In the Islamic world, irrigation technologies and crop introductions from India and beyond spark what some historians call an agricultural revolution. Kinship, law, and local institutions adapt too. As central bureaucracies thin out, bishops, abbots, tribal leaders, and local strongmen take over functions like dispute resolution, poor relief, and infrastructure maintenance. Not ideal, not always just, but functional enough to keep communities from disintegrating wholesale. This is where the sensational claims run into the brick wall of evidence. Civilization nearly vanished makes for a great book cover or video title. The sky did darken, crops did fail, plague did kill on a scale that's hard to imagine. For individuals and families caught in the worst zones, it absolutely felt like the end of the world. But mainstream scholarship, looking at ice cores, tree rings, pollen records, shipwrecks, coins, texts and ruins, tends to a more nuanced view. What happens after 536 is a catastrophic shock layered onto already fragile systems. It produces real demographic losses in many regions. It accelerates state failures and territorial reconfigurations. It shrinks and rearranges trade. It contributes to a long, coldish century that stresses agriculture and makes every other problem harder to solve. It does not erase writing. It does not wipe out cities. It does not send human societies uniformly back to the caves. Instead, it widens the gap between regions and between types of systems. Highly centralized, high overhead empires are more exposed. Smaller, more flexible polities or societies used to living close to the edge can sometimes ride out the volatility better and even take advantage of it. So how close did civilization come to vanishing? If by civilization you mean a specific Roman imperial way of organizing people, resources and ideas around the Mediterranean, then it came very close to the edge in some provinces, and in others it went over. If you mean complex, urban, literate, stratified societies anywhere on Earth, they never disappear. They mutate, they move, the centres shift. The better verdict might be this: the events kicked off in 536 didn't end civilization. They ended certain versions of it sooner and more violently than they might have ended otherwise, and they helped clear space for new versions to rise. They exposed how fragile, dense, interconnected systems can be, and how stubbornly human beings will improvise new ones when the old scaffolding collapses. And that, uncomfortably, is where the story loops back to us. So what, exactly, is the lesson of a dim sun in 536? Let's pull the threads together. First, the event itself. We're not just taking one monk's gloomy comment and spinning a global apocalypse out of it. We have independent lines of evidence, all pointing in the same direction. Contemporary writers from the Mediterranean to the Middle East to East Asia all talk about a sun that shines without brightness, seasons out of joint, strange cold, and failed harvests in the mid-530s. Deep in Greenland and Antarctic ice, sulfate spikes show up right where those people said the sky went wrong, signals of huge injections of volcanic material into the stratosphere. Not just once, but in multiple pulses across the decade. Tree rings from Europe, Asia, and the Americas lock in the same pattern. Narrow growth bands. Cold summers, years so poor that even long-lived trees, normally buffered against short blips, struggle. Texts, ice, trees. 3 different archives, all telling variations of the same story. Something big hit the atmosphere in the mid-530s and pushed global temperatures down for years. From there, the cascade is brutally simple. Dimmer sun means cooler summers and shorter growing seasons. Crops don't ripen. Pastures don't fatten animals the way they should. Marginal lands drop out of production first. Storerooms that would normally bridge bad years are emptied early. Stress in the fields becomes hunger in the towns and countryside. People sell assets, pull children out of whatever passes for school. Migrate if they can, riot if they can't. Hunger weakens immune systems. Bodies that could have shrugged off infections in good years start losing that fight. Diseases spread faster in crowded, desperate populations. When a new pathogen, like the Justinianic plague, shows up in that environment, the impact is multiplied. It's not just a bad germ. It's a bad germ landing in a system already tilted toward failure. But this wasn't one neatly synchronized global story. It was a patchwork. Some regions took massive hits. Others bent but didn't break. Some barely noticed the cooling at all. Yet they were connected by trade, by migration, by politics. Grain shortages in Egypt could raise bread prices in Constantinople. Caravan routes disrupted in Central Asia could ripple into markets in Iran or China. The lesson is less one volcano almost ended civilization, and more once the sky goes wrong. Everything we've layered on top of climate, food systems, states, trade, public health, starts to wobble together. And notice how we're even able to say that. No single source, ancient or modern, can tell this story alone. Medieval chroniclers didn't know about sulfate aerosols. Ice cores don't know about riots in Antioch. Tree rings can't see plague ships in the eastern Mediterranean. But when you line them up, Latin sermons, Syriac chronicles, Chinese court records, Greenland ice, Siberian larches, you can reconstruct an almost invisible disaster. A change in the transparency of the atmosphere, something no one in 536 could measure, but everyone could feel. That's another uncomfortable parallel with our own time. We are now the ones altering the sky, slowly warming, not suddenly cooling, but still changing the background conditions that everything else relies on. Our systems are far bigger and more technologically sophisticated than those of Justinian's world, but also far more tightly coupled. Faster, more global. The mid-530s remind us that complexity is a double-edged sword. It gives us buffers, backups, and tools. It also links our fates. If you've made it this far, I'm curious, where are you listening from, and what time is it there right now? Drop your location and the local time in the comments. Let's see just how wide this web of viewers really is. If you found this dive into 536 useful or unsettling in a good way, please take a second to like the video, share your thoughts below, and subscribe so you don't miss what we explore next.